Hello, this is Dr. Lori. Welcome to our next discussion on proportions, and specifically what I would like to do is to take that review to the next step and start talking about how we look at proportions with inferential studies. So, as you remember, we've learned a lot about descriptive statistics, just describing the data. See if we can get that to be a little cleaner. There we go. But the next step really is to think about, boy, my pen is getting weird, inferential statistics. So with inferential statistics, basically what we're doing is we're looking at relationships between two variables. And we've talked about inference and that kind of thing before. So with inferential statistics, we also have different kinds of variables, and we have different kinds of questions that we would like to be able to answer. So one of the first inferential statistical questions that we answered was whether here's our one sample t-test, whether a particular sample had a mean that was as expected. And so we had either a reference value from a population, or we had a specific thing that we were looking for that particular variable, and then we could run a one sample t-test. In this particular lesson, we're going to be learning about chi-square goodness of fit. And what chi-square goodness of fit does is it allows us to do a lot of the same things that we did with our one sample t-test. In other words, compare to some reference, except it allows us to do this as a test of proportions. And so we're kind of extrapolating the one sample t-test to a new situation. An example of a question that can be answered with the chi-square goodness of fit test often we'll use examples that are very concrete, but we would probably never sit around in public health and do this particular example. But we use it because I think it's very simple and easy for people to understand. So one of the examples given in your textbook is a fair die. And so if we have this die, it has 6 sides on it. Each side is numbered 1, 2, 3, 4, 5, and 6. And if we were to roll that a bunch of times, let's say 600 times, we would expect each side to be up. We would expect to end up with that as the result 100 times. And so if we have 6 even sides and each one of them shows up an equal number of times, then we would expect 100 of each. 1, 2, 3, 4, 5, and 6. So that's a very concrete example of equality. So we're measuring equality. So I'm going to put here chi, and it's abbreviated with the Greek letter x, chi-square goodness of fit. So we have this kind of other example. An example that we actually do wonder about in public health is possibly something like race ethnicity categories. Now, you'll remember that's a nominal variable. And let's say we wanted to know if our race ethnicity categories were evenly distributed. And we had possibly 5 different race ethnicity categories: Hispanic, non-Hispanic white, non-Hispanic black, Asian Pacific Islander, other. Those are, say, 5 different categories. If we were to collect 500 people and we were expecting them to be evenly distributed, we would expect 100 in each one of those categories. So that's an example of a kind of question that chi-square goodness of fit can answer. But I want to extend that a little bit. We may not expect all the categories to be evenly distributed, and chi-square goodness of fit can do that too. And so let's say we expected 40% to be Hispanic, 20% to be non-Hispanic white, 10% to be non-Hispanic black, 10% to be Asian Pacific Islander, and 20% to be other. We can also use chi-square goodness of fit to answer a question where we're not expecting the groups to be even. but we have a specific set of expected percentages. And so that brings me to an important distinction then between the one sample t-test and the chi-square goodness of fit. And this is kind of like a terminology that's used within biostatistics. We have tests of proportions, and we would do tests of proportions here on these kinds of variables because we have proportions or percentages that we're measuring for each one of them. So chi-square goodness of fit is a test of proportions. And we also have tests of means. And since we calculate the mean for scale variables, then the one sample t-test is a test of means. Both of them are testing against some standard or reference value. The one sample t-test is comparing to a standard mean. The chi-square goodness of fit is comparing against an expected distribution of percentages or proportions. And so now that we're in the inferential statistics realm, we can start talking about these different kinds of tests that we're interested in understanding. So the chi-square goodness of fit, we're really looking to see if the numbers within each category are as we expected them to be. With a one sample t-test, we wonder if the mean is as we expected it to be. So that is an introduction, an overview of the chi-square goodness of fit. In the next video, you'll be learning about how to actually run this test with the SPSS statistical software. Thanks for joining me.